Hey you guys, this is Mr. Millings, and in this video we are going to learn how to determine the volume inside a graduated cylinder after we place an object inside this graduated cylinder that has an initial volume of water. So in this problem right here, it says if the platinum on the triple beam balance shown below is placed in the graduated cylinder, we need to determine the final volume of the water. So let's think about this. We have a graduated cylinder here, and in this graduated cylinder, there's an initial volume of water. We're then going to take this piece of platinum metal, and we're going to put it inside of this graduated cylinder. And what's going to happen to this water level? The water level is going to rise. It's going to rise to a certain volume. And so what we need to determine is the final volume of the water after we place this metal in here. And so what we really have to do is we really have to figure out the volume of this metal. If we can somehow figure out the volume of this platinum, well, then we can figure out the increase in the water level in this graduated cylinder and determine the final volume. So let's think about this. The final volume, or VF, of the water that is going to be in this graduated cylinder is going to be equal to the initial volume, we'll call V naught, plus the volume of our platinum metal. Right? So stop and think about that. The final volume of the water that is in this graduated cylinder is going to be equal to the initial volume of the water that is in this graduated cylinder plus the volume of this platinum metal once we put it in here. Once we put the platinum metal in this graduated cylinder, the water level will rise by the amount of the volume that we figure this out to be. So how can we figure out the volume? How can we figure out the volume of this piece of platinum that's on this triple beam balance right here? Well, we know the mass, where we can figure out the mass. We can take the reading from this triple beam balance and figure out the mass of this metal. We also have a table of density values. We can figure out the density of platinum. In fact, if we take a look, the density of platinum is right here. It's 21.400 grams per cubic centimeter. So if we know the density of the metal and if we know the mass of the metal, well, how do we figure out the volume? Well, that's where the density formula comes into play. Density equals mass divided by volume. So if we know the density of the metal and we know the mass of the metal, how can we find the volume of the metal? Well, we can manipulate this formula and isolate V and get it all by itself on one side of the equal sign by multiplying by V first on both sides. V will now cancel. And now we're left with this formula. Volume times density equals mass. So now, how do we get volume all by itself on one side of the equal sign? You guessed it. We divide both sides by density. Density now cancels from the left. And so the formula that we're going to use to figure out the volume of this metal here will be mass divided by density. So if we figure out the mass, and we figure out the density by taking a look at this table, we can now figure out the volume. And once we figure out the volume of our platinum, we can just add it to the initial volume of the water that's in this graduated cylinder, and that will give us the final volume of the water that is in this graduated cylinder. So let's first take a look at the mass of this object. What is the mass of this platinum here that's on this triple beam balance? If we take a look, this little rider's at 200, this rider's at 30, and this rider, if we take a closer look, is at 2. It's not quite to 3, it's at 2. So we have 232 with 100% accuracy. Well, take a close look. We have 232.1, 232.3, not quite 232.1, 232.2, not quite 232.3. So we know with 100% accuracy that the mass is going to be 232.2. And remember, we have to go one past the level of precision of our instrument. So this instrument here measures to the 1/10 of a gram. If we take a look, there's grams right here. So we have to go one past. We have to estimate what this is going to be. And if we take a close look, we'll go ahead and call this 232.22 grams. So there's the mass of this object. Now, what about the density? If we take a look at our table here, the density is 21.400 grams per cubic centimeter. And so now, how do we figure out the volume? You guessed it, we're going to use this formula right here. Volume equals mass divided by density. The mass of this object is 232.22 grams. And the density is 21.400 grams per cubic centimeter. Take a look at what happens. We have grams in the numerator, and in the denominator they cancel, leaving us with centimeters cubed left over, which is a measurement of volume. And so when we put this in our calculator, when we take 232.22 and we divide this by 21.400, we are going to end up with 10.851. So here is the volume of this platinum metal right here, but this isn't our final answer. The question here is asking for the final volume of the water that will be in this graduated cylinder if we place this metal inside of here. So if we place this chunk of platinum inside this graduated cylinder, the water level is going to rise, and what will it rise to? That's the question. So to get the final volume of the water in this graduated cylinder, we'll take the initial volume. So we have to figure out by what increments this graduated cylinder is graduated by. So if this is 5 milliliters and this is 10, and there's 10 little lines here, each one of these lines represents 0.5 milliliters. And when we have a graduated cylinder that's graduated by 0.5 increments, we can only take our measurement to the 10th place for the level of precision. So if we take a look here, this is 30, that makes this 29.5, that makes this 29. That makes this 28.5, and that makes this 28. And if we take a look really close, it looks to be just a hair past the line here for 28. So we'll call this 28.1. So the volume here equals 28.1 milliliters. That's the initial volume. So the initial volume here is 28.1 milliliters. And the volume of our platinum, we just figured out, it's right here, is 10.851 milliliters. Now keep in mind that a centimeter cubed and a milliliter are the same thing. 1 centimeter cubed equals 1 milliliter. They're used interchangeably. We're going to use centimeters cubed for solid objects though. So we can basically say that this is 10.851 milliliters. Same thing. So we're going to add these together, and the final volume of the platinum that is on this scale here is going to end up being 38. Actually, it's going to end up being 39.0 milliliters, right? If we round to the appropriate number of significant figures, this has 1 decimal place, this has 3 decimal places, and when we add or subtract, we have to round our answer to the lowest amount of decimal places as the numbers that we added or subtracted. So we end up with 38.951, and that's going to round to 39.0 if we're using the correct precision here. So what is the final volume of the water going to be? It looks like it's going to be about 39.0 milliliters. So 39.0 will end up being right here, and so the final volume of the water, once we place this platinum in here, is going to end up being 39.0 milliliters. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.